So good morning. Welcome to day 3 of this workshop and second day of mine. So what did you do yesterday afternoon? Tried something out or went home? Viraj and I have been friends for nearly 11 years now. So he was teaching in the same college where I was teaching. I was a visiting faculty in the Department of Computer Science, where he was teaching in the Department of Information Science. And once we came to know each other well, I would attend his lectures and he would attend my lectures. After that, he moved to IISc. So I was giving a talk there. Before the talk, there was a break and they were serving vada and tea and coffee. So Viraj came there and they told me, I didn't come for vada, I came for your talk. Then he asked me whether I was writing papers. I said, I don't know how to write papers at all. So, and then we didn't have time, so he said he would talk to me later. The next Saturday, we were talking to each other. I said, we are doing these projects during summer. Then immediately he cut me short and said, why don't you come to ACM Compute at Chitakara? Why don't you give a talk about what you're doing? Then one Saturday, he also came to the college, saw our projects, and then he said a few of them could become papers. And we wrote 4 papers. He helped me out in it, and he didn't put his name. And out of 4, 3 became papers. That was, I think, some 4 years back. And because of Viraj, now I think I have 26, 27 papers now. I don't count. And he says I'm a researcher, but I always keep saying I am a teacher and not a researcher at all. We did one interesting project which has saved a lot of money for our college. So we used to have double evaluation of answer scripts in the final paper. And if the difference was more than some 9 marks or something like that, it would go to third evaluator. So what we did was this. The papers getting scanned and we had digital evaluation. So after scanning the paper, we said we will divide the answers of each student based on the question number and then collate them together so that answers of a particular question of all students in the class would come together. So each teacher would be expected to evaluate only one question for all the students in the college. Right? We have a huge number of students in computer science. In the first year, some 4 years back, there were 22 sections. And in computer science itself, we have 2 campuses. I think there are around 18 sections. Okay, so, and our idea, I think the intake is 780 plus 720, you can imagine. All other branches are getting closed, civil is closed, mechanical is getting closed. I don't know where we're heading. It appears as if only computer science is sufficient to run the whole world. Very scary in a way. Okay, so we did that project. The basic idea was to facilitate easy evaluation, right? If you're only evaluating the same question, you remember the context. You don't have to go back and look at the answers again. And also it could become faster. That was the idea. Our CEO said, because the same teacher evaluates for all students, you don't require double evaluation. He saved money there also. And that is being totally used. We made a proof of concept, but it is totally used now. So we tried a lot of experiments in the field of education, a few in the field of Indian languages. But I don't consider myself a researcher. I love teaching, I teach and hopefully stop very quickly. Okay. Last training I did for corporates was in October for Sony. After that, I gave a talk at ACM Jaipur. Then I gave a talk at IIT Gandhinagar. That was in December. After that, I haven't done anything technical at all. With my friend, I have gone to some high schools and given a talk to high school students. And recently in Mysore, I was with young kids, children in the age group of something like 6 to 10 or something. That was very interesting and challenging. Okay. I just checked out of the hotel, otherwise they charge for the whole day, right? If I don't check out before noon. My room number was 153. Anything interesting about it? 153? Huh? All odd number, that's interesting observation. Yeah, anything else to say? Would you know anything about 1729? Is that an interesting number? 1729? Come again? One is a? I like that. That's an Armstrong number. Would you know what an Armstrong number is? Okay, I'll come back to that. So it's all digressing, right? 1729. What is special about 1729? It's named after the greatest mathematician of India, Srinivasan Ramanujan, right? So what is special about that number 1729? It is the smallest number which can be expressed as sum of two cubes in two different ways. It is 10 cubed plus 9 cubed as well as 1 cubed plus 12 cubed. And how did Srinivasan Ramanujan come across the number? He was working in Madras Port Trust. He was writing some articles in math, and that got the attention of Professor Bailey from England. He invited him to come over to England, and there he got tuberculosis, and he was in the hospital. Professor Bailey came by a cab, and it seems he came and told Ramanujan, the number is not interesting, but it seems he said, no, that's a very interesting number with this property. Okay. So, okay, let's come back to this 153. It's called the Armstrong number. So, what is special about Armstrong number? Digits, cube the digits and add them, you get the same number, right? Okay. So now, can we write a small program for this quickly? You help me out, we'll write it. So maybe generate all Armstrong numbers between, say, 0 and 999, 3-digit, at the most 3-digit Armstrong numbers. Simple example. So we'll make a start and hopefully get some idea out of it, right? So can one of you help me in writing the program? You want the fans? I don't want the fans. What is it? Okay. So how do you generate all numbers between 0 and 999? We satisfy the property that the sum of the cubes add up to the number itself. How do we do? Some idea? Very, very simple, straightforward example. You divide and do it? Okay. Okay.
Then put it till that number becomes 0. And then find the cube of that. And sum is equal to sum plus cube. So if sum is equal to
I'm not checking whether a number is that. I'm generating all numbers. I have to I have to go to 0, 1, 2, 3 till 999 and check it.
put it in a form from I 2000.
We want to go to 1000. Okay. We'll do the way you're saying. Maybe then we'll modify. So we'll have a loop from, okay. Okay. Another while loop. Generate. So we're taking each number now and we have to check. Yeah, that do we require a loop again or do we require to somehow break into 3 parts? How do you break into parts? So how do you find the digit in the unit place? Let's say how about this? How do you find T? Yes. How do you find T? Would that be okay? This works, right? But we're using division, and division is normally slower than multiplication. Can we retry the same example where we avoid breaking into digits like this? We start with digits and form the number. So the idea we would like to use here is a bit different. So we can look up on that as some sort of a odometer or something, some sort of energy meter, whatever. This stands for the unit digit, this for the 10 digit, and this for the 100 digit. So what do we do? In the beginning, this will be 0, this will be 0, this will be 0. This will keep changing to 1, 2, 3, and so on. And what happens here? This becomes 9. What is the next step? This will become 0, and this will become 1. Right? I'm sure you would have seen such a thing at number of places, right? So can I use that particular idea? Instead of having division, I would love to use multiplication. So I will have a loop in H, which varies from 0 to 9. Within that, a loop in T, H standing for the digit in the 100th place. I'll have a loop in T where T stands for digit in the 10th place and U stands for a digit in the unit place. So I'll have a loop in a loop. In the innermost loop, I'll have all the 3 digits. I form the corresponding number, multiply these digits with the corresponding place value, add them, and also I get the cubes of these and add them and compare. Is that okay? So how do we proceed? So we are trying the same example in a different way. So I will have a loop in H. Okay. Then within that, I will have a loop in T. And within that, I will have a loop in U. Okay. So here, I find the cube of U, cube of T, and cube of H, and the sum. How do you form N? Can you tell me? Given H, T, and U, how do you find the value of N? H into what? H is the digit in the 100 place, plus right? Okay. Doing this is fine. So now we don't have any division at all. We only have some multiplications, right? So let's check whether the program is correct. Okay. Is this a good program? Okay. Good, bad, or ugly? Is that better than the earlier one? Maybe yes, because we avoided division. Okay, let's concentrate on certain portion here. We'll concentrate on these statements here. These statements do the cubing, right? What is the number of multiplications we are doing to cube the digits? What is the number of multiplications in this whole program to do the cubing? For each cubing, we are doing 2 multiplications, right? And we are cubing u, cubing t, and cubing h. So we are doing 6 multiplications. And we are doing that for every value of h, or rather every value of u. U varies 10 times. So that became 6t. That is executed for every value of t. T varies 10 times. So that becomes 600. It is done for every value of h. H varies 10 times. So it becomes 6000. Is it possible to decrease the number of multiplications, make it approximately 1/3 somehow, without changing the logic much? Can we decrease the number of multiplications? That will be another additional comparison in the inner loop. That means you require extra memory to do. I'll take that question a bit later. That is a total change of logic, right? I want to say it's the same logic, but decrease the number of multiplications to approximately 1/3. How do we do? Have you heard of something called loop invariant? Loop invariant is something which does not change in the loop, right? Let's have a look at line 21. We are cubing h for every value of u, correct? Is h changing in the loop? Or do you think we can put it somewhere else? Right? It's actually an invariant in the loop. So, do you think it's a good idea to move the line 21 to somewhere after 14 in part of the loop in h, not in the loop in u? Similarly, can we move this somewhere here? Would that make a difference? Right? So we'll try it out. Of course, it's too small an example to time out. I'll try to show you some examples where there is a timing concept. Okay? Are you with me that when you put a statement, you should be very clear whether it should be at that place or some other place. Right? These are beyond algorithms. Algorithms don't say much about it, but it is a requirement when you do it practically. You should show such things to the students. It can be done in the first course itself. Right? Keep discussing like this. Say, okay, can we do it better and things like that. Okay. So what I will do now is to remove this line from here and put that at this place. remove this line from here and put that here. Otherwise, I don't change anything. Okay. So now can you count the number of multiplications we are doing for the digits here? For unit digit, 2 multiplications, 10 times, 10 times, 10 times, so it's 2000. For cubing 10 digit, 2 times, 10 times 10, 200. For cubing h, it's just 10 times, 2 into 10. So it became 2220 multiplications instead of 6000 multiplications. Okay. So one of the most interesting concepts in development of algorithm is the concept of loop invariant. The way I would love to teach is this: start with the problem, take input from the students, draw it, write the program, and then keep on saying this is the way you can make it better. Okay. Which digits are we cubing here? Which numbers are we cubing effectively here? The variable names are h, t, and u. What numbers are getting cubed? What values? 0. Are you cubing 0? Are you cubing 1? Are we? Don't we cube when h is 0 here? We do know. We also cube when h is 1. Do we cube 10 by any chance? We don't. We only do from 0 to 9. Effectively, you're only cubing 10 numbers. We are doing it repeatedly. Our friend had a suggestion. So what do you want to say?
I was saying you make the cubes of this list ready, 0 to 9, and then for that digit pick that.
Yeah, so another possible way you can show a variation here is that do a pre-computation. If something is required repeatedly, do a pre-computation, put it in some data structure and pick it from there, right? So only we are cubing digits 0 to 9. To cube 10 numbers, we require only 20 multiplications, and we cube them and put it somewhere, then you should be able to access it. In which data structure would you put it? Huh? Hashing is not very meaningful. Okay, I'll take the question a bit later. The simplest thing is an array. You don't require to, a single will do. Because the index itself can indicate whose cube it is going to be stored there. Right? Because hashing is an interesting concept. I'll just remind me if I forget. So next version that we'll try now is this. Okay. So what I will do is do a pre-computation. I will have an array of cubes. Okay. And what do you think I should do? Do I require this? No. I don't require this. I don't require this. That means I don't require these variables, right? And what do you think I should do here? I have to get the cube of u for a value u, for a value t and value h, right? What do I do? Use the array. Right? Other things won't change. Okay. But here we have used two different techniques. One is definitely a right thing to do, move the invariants out, put the statement at the right place. Second, also use the concept of storing earlier. You sometimes use the word caching for it. We do not know which is better. The reason is when we index an array, it has some computation. It has to take the base pointer value, to that add the index times the size of each component, right? That requires some computation. So that is faster, or going through that is faster. So in some cases it's difficult to make out which is better. Only thing in such case is to measure and see which is better, right? So anything you want to ask about this development? Yeah.
So now when we are calculating by using multiplication,
Huh.
we use a predefined keyword like power.
Is
Then
the,
any effect has been applied in
okay, you're talking about the function power. The function power gives only an approximate value. It returns a double. Maybe I can show you that. Right? By the way, which is the first command you would teach in case you teach Unix? Which is the first command you should learn in case you play with Unix? Huh? Man. And the first command you should try is man. How to use man? Online manuals. Without that, there's no way we can work in Unix. Okay, let's come back to your question. Power takes doubles, returns a double. So you get an approximation, right? And any function call is likely to be costlier compared to a simple multiplication. And second thing, you want only integer results. The minute you call this, you could be in trouble. Yesterday, Dr. Viraj had given one question number 4, right, which I was trying to tell you. Fourth, I think it was. It had check the prime number less than square root of something he had put, right? Integer of square root of x. There's a problem. The problem with square root is that it gives an approximate root. Assume that you're trying to find square root of 4. What you expect is 2. You may not get that. You may get 1.99999, right? These floating point values are stored according to the standard IEEE 754, right? It uses the Mantis exponent format. It's approximate. So general rule is that if you can do your computation in the integer domain, do that. You must have a very good reason to go to the floating point domain. If you're doing engineering applications, you can't avoid that. In most of the computer science applications, we prefer to stay in integer domain and not floating point domain. And the rule of programming is never compare floating point values for equality. You never say something like SQRT of n equal to I. No, never. The way you compare will be SQRT of n comma I, take the difference and the absolute value of it, right? I remember in IIT Madras, we are working on a old machine, IBM 370. The computer room was double the size, and the hard disk was the size of a normal washing machine, 10 MB. Right? You can't imagine that. And whenever we used to give program there, we had to do code punching. We had no control over that ourselves. It would produce outputs on paper. If it exceeded 50 pages, it would stop. Okay, there's infinite loop or something, right? A friend of mine was simulating IC engines. So that went to infinite loop and he got 50 pages of output. We used to call such programs as paper generating programs, right? So the mistake he had made was that he was trying to compare two floating point values for equality to stop the program. It never happened. There could be some small difference at the last mantissa bit, right? Avoid floating point values as far as possible. Okay. There's a question about hash, right? Do you know Python? But where have you come across hash? Is it?
Data structure itself.
Okay, fine. So hash is a data structure which is very heavily used in number of places. And always we have a question while designing, should we use an array or what is called list in Python? List in Python is basically an array of pointers. It's not a linked list, okay? Should we use such a thing or should we use a hash? If I can access the element based on an integer, most probably I should not be using a hash. If I have to access the elements based on an index, which is not an integer, then use a hash. If it is a string, maybe we want to take your name and map it to your profile, there should be a hash because I'm indexing based on a string. But if I'm doing it based upon maybe your Aadhaar card number, I should not be using a hash. I should use an array. But there's another interesting question about it. The elements are close to each other. They are packed. Such a case, use an array. If sometimes the elements are not close to each other, assume that I make a huge array to hold information about all of you based upon your Aadhaar number. They won't be contiguous, right? So lots of spaces will be wasted in the middle. In such a case, I may want to use a hash. So the rule is like this. If the indices are not integer, use a hash. No choice at all. If the indices are integer, they are dense, they are close together, use an array. If they are sparse, use a hash. That's the golden rule of programming. Any other query? 2D array, why do you want that? Integer and that. Yeah, so you basically wanted a 2D array with 2 columns only.
Yeah, one column for the value of
Yeah.
next
Yeah, if you can avoid that. Why unnecessarily, right? Okay. So now we'll start. We'll have a small test. If for yourself, I'll just run through the test and then we'll answer it also as we go along. You can count for yourself how much you get. I'm not going to ask you unless you come and tell me that you got 11 on 10. Okay. Fine. Some of them are what we discussed yesterday, so they should be simple. Maybe you call it A, B, C, D or whatever. I don't have those indices, the numbers. Maybe in your paper you can pick one and then we can discuss, or we can discuss later. This was a question we got in finals of EdTech, IIT Madras. Please read the question correctly. Assume that there is a language which has stack already built in. There is a type called stack, but it supports push and pop as expected. There is no array in the language. So can I simulate an array using a stack?
Is it accessing the element only?
Okay.
No, if it is stack.
Okay, just assume that it's only way I can build the stack is by pushing, right? can I get the ith element of the array? For me, it should be an array. How do you get the ith element? Get the ith element of an array where only stack is the underlying data structure. You can't lose the elements, right? If pop, it will go out somewhere. So what do you think we should do? Okay. Go ahead. Can we listen to him? So he has a solution to get the ith element of the stack of the array. Yeah. Yes, sir.
Pop I minus one element from the first stack, push it on the second stack, and then pick the ith element.
And then
Pick the ith element from the.
after that, put them back again. No, you're not removing the element. You only get the value, ith element. Get the ith element and put all the elements back again on top. No, you're not popping in this. I said only get the ith element. If you had to remove the ith element, then you have to remove that way, right? So what you can do with this, to get the ith element of my array, you remove I minus one elements on the top in the stack, put it to another stack, access this element and do whatever you're supposed to do it, and again bring them back here. So it's possible, right? That means the first one is not an answer. Now the question is, to get the ith element, how many elements have to move around? Is it proportional to the number of elements in the stack, or is it always same time? It depends on the number of elements here, right? So if there are n elements in it, in the worst case, what is the number of operations? N. So for the operation will be linear. So the answer for this is 2. How many of you got it? Okay. You must have got it. So you're not raising the hand. So this was one of the questions we had asked in the final exam in IIT Madras. We were asked to write a program for doing it, not just give this answer. So we would get very, very funny questions in IIT. This should be very, very easy to answer. Yesterday, day before we had discussed it. I will share it anyway with you. Anyway, I'll share with you. No, you don't have to take photographs. How many of you think it is the first one? The first one? The second one? All three? No, we have seen the other day, right? The code for insertion became so simple. Earlier we had some 4 test cases, right? It all boiled down to just one case at the end. Do you remember it? First one is the one. We discussed it the other day. See, I'm an old man. My memory is highly corrupted. You're all very young. So the first one is the answer. Insertion routine became extremely simple when we did this. This was an exercise for you to try, right? I don't know whether you tried it. I'm sure you would have tried it last afternoon. Second one, searching. Okay. So we tried it. So searching becomes faster because in a loop while checking, we can knock off one condition and we copy the key being searched to the last position. Okay. Adding a node to a queue, 2 I think missing there. That's what I think we discussed it day before. When you add a node to a queue, NQ, second, Not single node, empty node. Both, okay, I like that answer. So most of you are saying 3 is the answer because when you add to the empty queue, both the rear and the front will change. This is a bit tricky question, so maybe read correctly and then think. Huh? Why? Oh no. Okay. This is one thing you should very clearly understand. When you talk about the big O notation, we talk about what is called the asymptotic complexity. We do not consider n being small. N has to be very high. Only then we talk about it. If you're looking at a special case and answering it, that's not the consideration at all. If it works that way, even if n is big, then it's okay. Right? This is a very common error people do. Yeah?
Third one.
Why?
That depends on how we are managing the list.
How?
If suppose we are keeping track of the last node.
I like that. Yeah. So very interesting. So it depends upon the implementation. Normally people would say it is linear because I have to traverse all the nodes. But my list structure could have 2 pointers, one point to the beginning, one point to the end, last element. In that case, it is only constant time. Directly can go there. Right? Very good. Do you think these sort of questions can be asked in your exams? Possible, right? And they won't fail. We actually keep joking about evaluation. By any chance, do any of you know Kannada at all? You don't have to know. You know Kannada, okay. You know what huli means. You know what huli means. Huli means tiger. Let's say there is a question where the student is supposed to answer it as huli. If he writes ili, ili means mouse. You must give half the marks because li is matching. Okay. So another friend of mine was saying, the question is how many legs a cow has. It's a 4-mark question. If it says 3, you must give 3 marks. Right? That's what we do anyway. So we don't want to fail people, right? I rarely fail people, but they may not get the S grade though. Okay. I missed one? Okay. Sorry. How many of you have not heard of this name? Dijkstra. It's supposed to be pronounced as Dijkstra. Shortest path. Any other place? In OS? Operating systems? No, no. Deadlock. Related to deadlock, related to something. Semaphore. Semaphore is creation. He was the first person developed a multitasking operating system called T.H.E. I don't remember what it is. He was from Netherlands. He was a Dutch. You name a field in computer science, he has contribution there. One of the greatest persons to ever live in computer science. I think he died in 2004 or so. Okay, and something interesting about him is the way he writes. His English is unusual. A sentence will span over at least 4 or 5 lines. Halfway through it, I would forget what I read. I had to go back and read all over again, right? So, when Dijkstra married in 1952 or so, he is then study in physics. So when he married, it seems in the Corporation of Amsterdam, he had to put down his profession. He had to write the profession. It seems he wrote the profession as programmer, and the corporation authorities refused it, saying it's not a valid profession. And in the records of Netherlands, even though it seems, it says theoretical physicist, and he says he has done no work in that field at all, right? So Dijkstra has come with a very interesting algorithm which allows you to move back and forth in a single linked list. Okay, normally it's not possible, right? You can only move in one direction. But if you're allowed to change the list, you can move back and forth. But of course, can do only once, right? The way we can go about doing it is something like this. Okay? So if I look at a snapshot here, it will be something like this. At any point, the list appears to be two lists in two different directions. So I'll have a pointer to this. I'll also have a pointer to this. Now let's say my requirement is to move to the next node. So what I do here is this: to move to the next node, I will change this pointer. Oh no. I'll take all the three, hope one of them writes. Maybe I should keep it here. Cache the pins, right? Like this. I will change this pointer to point to this. I will change this pointer to point to this. So I can move forward in this direction. I can move back in this direction. Every time I'll make some three changes, using which I can move back and forth. So this is a very interesting algorithm of Dijkstra, which provides me flexibility to move back and forth in a list at only once. I can't do it simultaneously, right? So this is a very interesting, challenging problem you may want to ask your students to implement. Okay. So now we can answer this question. Second one is the answer, right? Okay. We'll take the question later. I think I haven't discussed much, so maybe I should come back to this. Maybe we can digress to discuss a few things about pointers as we go along. When you play with, okay, I'll talk about pointers for some time and then we look at it. So when you talk about pointers, we talk about aliasing. We talk about dangling pointers. We talk about garbage. Okay. And one other interesting concept we should discuss here is the concept of virtual addressing. Okay. That's come from OS, right? All subjects are interrelated. They're not independent. Okay. So let me do one thing. I will write a small program. I want you to find the output. Okay, just trace it. I'm not making a bug. I'm not asking you to refute that. It's going to work, but I want you to find the output. Okay. So use paper and pencil. Do not key in this. Okay. Use paper and pencil and find the output for this program. Okay. So I'll try to do it quickly, and through that I'll be able to show one of these points. Not a very meaningful name, but okay. I'm writing in a single file just to show that it's visible here. And I'm hiding the name. Okay, couple of more statements, I'm through. Okay, so you can see the whole program on the screen. This is the client program and this is the function. I'm calling the function and display something for you. And A and B have been initialized 25 and 15. So please walk through it, take a few minutes. Tell me what will be the output. The first thing I think students should learn is to walk through a given program, draw the stack and see how the variables change. Take your time and do it and let me know. So this is the client program and this is the function. So the way I expect you to walk through is this. So I write the stack like this. Okay, I have variables A and B. The value of A is 25, B is 15. When we call a function, we get what is called an activation record or stack frame. In that, we'll have parameters, local variables, temporary variables the compiler creates, return address, right? And we don't show the return address here. We'll only show other variables. So I have a variable called P and a variable called Q. These are parameters. P points to A and Q points to B, right? And then I have a couple of local variables, M and N, and they're initialized. What does M get? M gets star of P. So P is this. Star of P is this location. The value there is 25. So M becomes 25 and N becomes 15, right? Please go ahead from here. These will keep changing, right? So see what happens at the end. And if any of you got the final result, let me know. There are two outputs, right? But this is one thing which students should learn in the first course. Given a program, they should know how to walk through, how to write the activation record, no matter which language you consider. Difficult for you to see from here? Can? Okay. Or if not, you can move to the center, whichever. Any answers for me? A is? A is 5, B is 3. Okay. So I got one solution. So what happened? Oh, you got 2 and 1. Okay. After this if statement, did you go back to the loop again? That if is within the loop, right? So you cannot come out of the loop until m becomes equal to n. Did you make the mistake? Just check. See here, this should change, right? Don't write that way. That's the worst thing. It's very difficult to make out. When you came here, so you came to the loop. 25 is not equal to 15, correct? Then you come to the if statement. 25 is greater than 15. What should happen? M should change. Where is M changed? It's not changed there. Change it there. In that itself, location you write here, right? You change it there itself. Yeah, I got one answer is 5-3, other one is 2-1. So I don't know which I. Yeah. 5-3. Okay. Did you try? Okay. I want to just see. This is not the way to do. That's the reason I wrote that. Because here you can easily go wrong. See, the way it happens internally is that there will be some location. There it should change. When you do it like this, answer could be still right, but you may use a wrong value sometime, right? Because the variables have changed, so you may not know the exact value at that point. Please try to follow this. This is proven way of doing. Yes, sir.
Activation stacks.
Huh?
Is it activation stack?
This is a stack.
Activation stack, right?
Yeah, activation record. Other stack frame. Okay. 5-3. What about you, Likita? You want to change your answer now, or you never want to become a doctor, right? By the time we change the answer, the patient will be dead. 5-3. Okay. Do not write the variables separately. Please follow this proven way of doing. Okay. We'll go through the loop now. M is not equal to n. M greater than n is true. Subtract n from m. So this becomes 10. Don't come out of the loop now because we are still in the loop. We have to check the condition. M is not equal to n. So what do? M greater than n is false. We go to the else portion. N becomes 5. M is not equal to n. Again go to the loop. In the if statement, that is true. Condition is true. So this becomes 5. Now the condition is false. We come out. So what do we do here? We divide star of p by m and put that back to star of p. So p is this, star of p is this. Take the value, the 25, divide by m, 5. So we get 5. Where do you put it? In the location to which star of p points to. So this becomes 5. Then star of q is this, the value is 15. Divide that by this, we get 3. And where do you put it? In star of q. We come to the end of the function. This activation record is conceptually popped out. We are back here. So this is the right result, this is not. Okay? We'll extend that now. Are you okay with this? Please do teach this in the first course as early as possible. they should know how to write the activation record, right? So now what I will do now is a small change, continue with the same here. Okay, that's it. So at this point, this remains. This is still there in the memory. We call a function, we get a new activation record. Do observe that I'm passing the pointer to A twice. Okay, now tell me the result. Do draw like this and try out and tell me what you get. Oh no, this I'll change. Wait. I think you'll not be able to see easily, right? So this is the line added. Okay. Where is 5 and 3? A. Please observe that I'm passing the pointer to A twice, and that makes a difference. Yeah. Only I got A, only one way output. One. It's a very clear indication you didn't follow what I did. You're not following what I had asked. You're not following me. You're not following me.
Program will execute again.
It's okay. Only last portion will change. Don't have to worry too much. That's what I said. You can start with this activation record. And then can do what is required. We have just A equal to 5, B equal to 3. We call the function. Pass address of A twice. So both P and Q will point to A. No, correct. You draw and see, that's why I'm asking. Okay. No way. I'm very happy that at least I got one correct answer. What about this table? Any answer from your table? No answer. You're still discussing. Okay. Huh? One. Okay. Shall we try? 5, it can't be 5 at all. Okay. Can I have your attention, please? let's try this. Okay. So I have variables A and B in main. A is 5, B is 3. I call the function. When I call the function, what do I get? I get parameters P and Q. What does P point to? Not 5, to A. P points to A. Where does Q point to? A itself. Okay, good. Now we get the values for M and N local variables. P star of P is 5. Q is this, star of Q is this, 5. Now we enter the body of the loop. What happens? Is the condition true? False. So we don't enter the loop at all. It's top tested loop. We come out of the loop. When you come out of the loop, what do we do? From now, please watch. Where is my black pen? Can you see the black pen somewhere? It's here, okay. Okay. Please watch what happens. Star of P slash equals M. P is this. Star of P is the value in the location 5. We divide by 5. So what do we get? Where do we put it? Where it? It is 2P, star of P. So becomes 1. Next, what do you think we should do? We should take star of Q. What is star of Q? 5 or 1? 1. And we divide by N. What do we get? So we come out of this and the result is this. Indian contribution to mathematics, right? All of you went wrong because you felt star of Q also is 5. Okay? The point to note is, okay, our friend was able to get it correctly. He's the only person that got it. Thank you. Okay, yeah, clap. Yeah, okay. Okay. The problem that you should observe here is that both P and Q point to the same location. When you change star of P, effectively star of Q also has changed. Unless you do it like this, you will not be able to make out. And this particular aspect of pointers is called aliasing. Aliasing is something we can't avoid. It happens. But we should know that there is an aliasing. If two pointers point to the same location, it's called aliasing. In C++, it can also happen through the concept of reference, in case you know C++. Okay? So this is one point. There are two other points I want to discuss as we go along. Okay. Was that interesting? Yes. Okay. Okay. Maybe before that I should give an example. I didn't run the program, right? Maybe I should run the program and show you so you believe in me. Okay. I want to discuss about the concept called the return mechanism. Okay. So again, if you understand from the memory point of view, many ideas become much easier to explain. So how would this particular piece of code work? Okay. Nothing really great in this, but my idea is to explain how this works. Okay. So let's always try to understand and follow the concept of activation record. Okay. So how would the thing start? We start from the main program. So the activation record of main will be here, which has three variables, A, B, and C. A is initialized to 10, B is initialized to 20. What about C? What will be the value of C? What is the value? There is a location already. Or will that be 0? It will be some unusual, some junk value. If the variable is global or static, it will be 0. That's in C and C++, right? But if automatic variable on the stack, it will be uninitialized, some junk value. We should not use it. That's the meaning of it. So when the function is called, what will happen? When the function foo is called, assignment works right to left. So we call the function first. So we get the parameters x and y. We are not creating any local variable per se. And x becomes 10, y becomes 20. There will be return address, we are not showing it. Then what happens after that? What do we do with 30? Where does it go? We are doing addition. Okay, now we got 30. Where do you put it? But C is not on to me. Within foo, do you know C? Within foo, I don't know anything about C. Right? Because somebody else may be calling foo with some other variable also. So this is one thing which you should clearly understand. In all languages, return is always through a temporary. A temporary is one the compiler creates. It could be a register, could be a location in memory. So this is the point I want you to make out clearly, that there will be some location here which is called the return object, and this return object is always a temporary. What does temporary basically mean? It means there is no name for it, and we have no control over the lifetime. The compiler will decide to create at some point, remove at some point. We have no control over it. We can just use it directly like this, but I can't give a name, I can't refer to it again. So return is always through a temporary in all languages. And so what happens here, this sum 30 will go and sit here. This also, okay, this writes, good. Okay. Once that sum is copied here, this is removed, and this 30 is in turn copied here. That's the way it works. Okay, nothing special about this, but I want you to understand the concept of the return object. It's something outside the activation record of the caller. It should be available to the callee. Some way the compiler will take care of it. It could be through registers or memory location. And whenever you return something, that goes to a temporary. Are you okay with this? Now please, shall I? Okay. Please have a look at this. Maybe you can write something similar and see what could happen. Call the function with a variable and see what happens. Okay. So take this, and this is the function definition. Draw the activation record the way I've been doing now and see what happens. We are trying to talk about final points of pointers. The first thing we started with an aliasing concept. Now we are looking at one more. Maybe after this we'll take a break. while teaching a course in C, do read Kernighan and Ritchie, do read C puzzle book, do not look at other books. Right? There are, I think, less said the better about other books in the market. In our time, there were no books. In your time, there are too many books, too much material on the internet as well. So finding the right thing is more difficult. 2 minutes. Done? So what happens in this?
He will point to A.
P will. No. P would not point to A. Okay, we'll. Shall we try it out? Huh? Yeah, P should point to X, and where is X? Okay, let's try this. It's a pretty simple one, but an important one. Please watch out. What? You can't see. Okay, I'll keep moving. So A is 10. P is at this point uninitialized. Are you okay with this? And we call the function foo. Okay. And what does that have? That has something called X. And what does X get? Pointer to A or 10? 10. It's just parameter passing of integer 10. Then what do we return? Return a pointer to X. Where will that be stored? The temporary. So there's a temporary here, which is stored this. Okay. After that, what will happen? The activation record is removed. This is removed. Then this value is copied here. What does that mean? You are given a key to a house which has been demolished now. There's no house anymore. So we have a pointer to a location. The location is conceptually not existing. Physically, it could be still there. That's the reason we get lots of unusual problems. So this is a case we have a pointer but no location, and that's called the dangling pointer, right? So this is something which is a dangerous one, and in our program, it should not happen. But I'll tell you, 90% time this code works as if it is correct. P will get a pointer to a location that will also have the value 10 and so on. So why does it happen is another interesting thing we'll discuss right after tea. Okay? How are you finding the discussion today? Is that okay? Boring? No? Okay. We'll come back and continue.